For today's lesson, I'm going to sidestep for a second. We're in the middle of section 4.2, but I'm going to take a sidestep and we're going to work on a skill that we're going to need to use in this section and in the sections upcoming and the rest of this chapter and in the rest of algebra. Something that we need to know how to do. It's solving an equation and getting it in function form, or also function form as it says here in the direction, or also a way we're going to hear that described later in the chapter is slope-intercept form. So either one of those ways, if I say either one of those phrases, this is what we're talking about, or what we're talking about today, I'm going to show you. Okay, what does it mean to put an equation in function form or slope-intercept form? It's a way that we typically see equations in two variables when we have x and y, and it'll help us be able to graph using two of the three methods that we're going to learn. The third method will be something we can use standard form for, but in the methods we're using right now, which is finding order pairs, and the method we're going to use soon enough, which will be slope-intercept form, we're going to need to be able to put an equation in slope-intercept form or function form. What that means is, and just kind of a brief definition, and I'm just going to give out a worksheet today that the students can work on, and we're going to go through the problems together so they can get the idea, is when we get an equation so that it's y equals, and then my expression is on the other side, like let's say y equals 2x plus 3. Or y equals, let's write another one up here, 5x minus 8. Okay. When I put an equation in slope-intercept form or function form, it should look like this, where I have y equals on one side. I have this equation solved for y, and the rest of my expression is on the other side. So this one too, y equals, and everything else on the other side. So as you'll hear me describe it sometimes, I'm going to talk about trying to get y by itself, or solving the equation for y. All these things are steps that I'm doing to get it in slope-intercept form. And when we get an equation in that form, it's a lot easier to graph using, again, like I said, a couple of our methods. So we're going to work on that today. The nice thing about this is that we learned all these different tools, all these different skills in Chapter 3 of how to solve equations, how to manipulate equations, how to move numbers from one side to the other, combine like terms, all those things within an equation. All those things are things we're going to use to get an equation in slope-intercept form. The only difference is we have two variables in the problem now. We have x and y. But other than that, all the skills, all the tools that we learned to work with equations in the last chapter are going to be in play in this section as well, or when we're doing this, when we're solving an equation to get it in this form. So like for this first one, it says 4x plus y equals negative 10. So this first problem here is what I'm looking at. We'll go through some of these together as a class. In this particular one, I'll talk about, again, trying to get the equation in slope-intercept form. Or again, as it says here, in function form. Either of those ways means the same exact thing. I'm just trying to solve this equation for y and get y by itself. Well, again, in equations like this, when we're trying to get a variable by itself, we usually try to eliminate the other things that are on that side. So there's a 4x right here on the left side with the y. So I'm going to try to get rid of that, and we know how to get rid of that is by subtracting 4x from both sides. When I subtract it from the left side, it'll get rid of the 4x on the left side there, so that's gone. Now I just have y by itself on the left side. That's what I want. This equation will be in slope-intercept form as soon as I'm done figuring out what's on the right side. So it says y equals. Over here I have negative 10, and then I'm subtracting 4x. So again, both those numbers, or both those terms, we can think of having a negative sign in front of them. So just when I write them, it doesn't matter what order I really write them in. I just got to make sure I keep a negative sign in front of each one, or a subtraction sign. So I'm going to put negative 4x, and then I'm going to put minus 10. I write it like this because very often we see the term with x. That's usually the first term we see on this side of the expression, and then the constant's usually the second term. It doesn't have to be like that, but that's just usually the way we'll see it in the book. That's the way I'll write on the board, and that's the easiest way to deal with the problem very often when we start evaluating too. So it's just nice to have that x term first. That's just kind of standard notation in how you write it. So, but it doesn't have to be, but that's usually how you're going to see it. So that's the way I'm usually going to write on the board as well. With the term that has x in it, I'm write that first. So, and again, maybe the one thing that can be confusing for some students is this is really the end of the problem. And when we're putting an equation in slope-intercept form, and today when we're working with this skill, I don't want them to go any farther than this. I just want them to solve the equation, so it's y equals everything else on the other side. So solve the equation for y, and that's all they have to do for these particular problems. We'll go on to the next problem here, number 2. Again, we'll do a few of these here in class, so I'll get them started, and then the students will work on them on their own. But this won't be per se an assignment in our class, but it's just something that I want to work on together so that we can get better at the skill. Then when we use it to graph, it'll be something that we can we can reference and use effectively. So we'll just work on it here today so we can all get better at it. So the second one says 3y minus 9x equals 27. So again, what I'm trying to do is get the equation in slope-intercept form. When I'm done with this, I want it to be y equals, and then the rest of my expression on the other side, the rest of my equation, everything else, all the other terms will be on the right side. If I'm trying to get things away from this y term here, here it is. If I'm trying to get things away from this, well then I got to get like this minus 9x, it says. That's what I have to eliminate from the left side. To do that, I'm going to add 9x to both sides of my equation. When I do it to the left side, subtract negative 9x plus 9x, and those essentially cancel out, and they're gone. So that's what I'm trying to do, is eliminate it from that side. All I have left now is 3y on the left side. On the right side, again, I have 27 plus 9x. So you could write it like this. This would be 27 plus 9x, and that's fine. But again, as I kind of explained in the first problem, I'm usually just going to put the term with x first, just because that's commonly how you'll see it. So don't have to, just how we're used to it, so I'm going to stick with that trend. My next step here, now I have 3y on the left side. So again, just like when we're solving things in chapter 3, if I'm trying to get the variable all by itself here, and it says 3 times that variable, I got to divide by 3 then. And one thing I'm going to start doing more, kind of really trying to explain this year, is making sure everybody understands when I divide this side by 3, it just means I have to divide this side by 3 as well, but that means I just have to divide every single term that's on the right side by 3. So you could write it like this, kind of like I very often on the board, I have in the past, wrote it like this, saying that I just have to make sure I divide each of those terms by 3. Here's another way you can write that as well. You just know that you have to divide every single thing. If I divide this side by 3 in an equation, I just have to make sure I divide everything in the equation by 3. So these terms, I can split it up and just put each one over 3. That's totally fine. Whenever you're solving an equation in algebra, whenever, as long as you do the same thing to each term, it's fine. It won't change the equation. So if I want to divide everything by 3, I just have to make sure I divide each individual term by 3, as I'm showing here. If I wanted to multiply every term by 4 or 5 or some number, I'd have to make sure I multiply each term by 4, and then it would not change the equation. It wouldn't change the answers. It would just maybe help us solve it, but it actually would not change the solutions of the equation. So this is another way you can write that, though. If it helps you remember, just put a 3 under each one of them to make sure that you divide each term by 3. So if I'm dividing each term by 3, I divide the 3's over here. That gives me y by itself on the left side. 9 divided by 3 gives me 3, so 3x. Plus 27 divided by 3, which gives me 9. So this equation in slope-intercept form is y equals 3x plus 9. So now I've gone through the first 2 problems, and I'll probably let the students work on some of the problems here in class so that they can try to get a feel for it themselves and see if they can do it on their own. I'll probably come down and then talk about some problems like down here at the bottom, maybe like 10, 11, maybe even 12. So I'll just go through those kind of briefly now as well. They're still doing the same things we were doing up top, but maybe there's just a little extra something I can talk about in these problems. So in number 10, so again, I'm trying to get the variable y by itself, or solve this equation for y. So what I got to do is first subtract 15x, just like we were doing up top here. So I better keep the x with it, but subtract 15x from both sides. That'll eliminate the 15x's from this side. Now I have, just remember that subtraction sign in front of the 5y. That means I have to think of it like negative 5y when it's still on the side. So negative 5y equals negative 15x plus 20. Again, I'm going to put the x term first. It doesn't matter which order I put it in, but that's the way I like to do it. I'm going to divide both sides by negative 5. And again, here's another way to write that. Just make sure I divide each and every term by negative 5. If there were like 6 more terms or a couple more terms on this side also, I would just have to make sure I divided all those by 5, or negative 5. Just for example, I'm just kind of changing the problem here temporarily so we get the idea that if I had all these terms on this side, then I just have to make sure I divide every single one of them by negative 5. As long as I do that in the equation, it does not change what my actual solutions are for that equation. So just kind of showing the point, or the idea of what's happening there when I divide by negative 5, what I need to do. So this on the left side, just have y, that's what I want. Negative 15 divided by negative 5 just gives me positive 3, so positive 3x. And 20 divided by negative 5 gives me negative 4, so I'm going to write minus 4. So y equals 3x minus 4 for number 10. I'm going to walk through number 11 here because I'm going to show us one thing that will be helpful for us later down the road in this chapter once we start to get into sections 3.1 or 4.4 and 4.5 when we're graphing using slope-intercept form. I'm going to start solving this one just like we've been doing the other ones though. So to get the variable y by itself and start solving this equation, getting it in a slope-intercept form, I'm going to subtract 2x from both sides first to start. That'll get rid of the 2x's out here. Again, this subtraction sign tells me it's got to be like negative 3y when I keep it on the left side. On the right here, I'm actually going to write 6 minus 2x for a second here because that's what I have, 6, and then subtract 2x. So I'm just going to write that, 6 minus 2x. And then I'll show you why, or to that point I want to bring up here in a second as we go through the rest of this problem. Now I'm going to do like I did in the other problems. To get y fully by itself, I got to divide both sides by negative 3. So I got to divide everything by negative 3. When I do it on the left side here, the 3's cancel out, so I just have y equals. That's what I want on this side. On the right side, 6 divided by negative 3 gives me negative 2. And then now if I look at what's going to happen here, I have negative, this, I have to think of this like a negative 2x, so keep in mind that subtraction sign. Think of this like negative 2 divided by negative 3. Well, realize that's going to give me a decimal. A negative divided by negative gives me a positive number, so I know it's going to be plus something. But it is going to be a decimal. Now here's the thing that I want us to get used to, is that when we're graphing equations, and when we're working equations in this particular form, which again we call it slope-intercept form, when we're putting equations in this form, and especially later in the chapter when we're graphing, we'll find it's much easier to not turn this answer into a decimal. We'd actually just rather leave it as a fraction, just like it's going to be. This is the number 2 divided by the number 3. Well, that's exactly what this fraction says, right? 2 divided by 3, and then I have to keep the x with it, but I'm just going to leave the answer like that. That's actually the best form I can put this answer in, because again, as we get later in the chapter, we'll kind of realize why. But for now, I'm just going to tell students, leave an equation like that if you get to this point. It actually is more helpful when we start graphing using slope and using our y-intercept, things that we're going to talk about later in the chapter. So from now on, if you see some kind of problem like this where you're solving it for y, and you end up getting to a point where you got to change something into a decimal here, like that term that's with x, go ahead and leave that as a fraction. Again, just kind of trust me for now, and in the future, we'll explain it more why it's better to leave it in that form. And maybe I'll go through one more problem here, maybe just this last one, number 10 at the bottom, just because it's got, I guess, something a little bit different in here, but not too much, something I think we can handle. Again, if we're looking at this problem, I'm going to try to solve it for y, try to get it in slope-intercept form. So I got to start eliminating stuff on the left side here where y is. So first I'm going to subtract 4 from both sides, and just realize in this problem, this isn't too new, but when I subtract 4 on this side, well, there is a 4 or a constant I can combine that with on the right side. So over on the left side here, I'm going to have just 6y, like I should have. But on the right side, I'll have, well, 12x. I haven't done anything with that yet. But I have negative 2 minus 4, so I can combine those like terms in this problem. So far in this worksheet, we haven't had any of these, so that's why some people may forget just that they can combine terms, just like we did in chapter 3 here. But it's negative 2 minus 4. So that's going to be minus 6 now in my problem. So just realize I can combine like terms just like I've done in the previous chapter. Anytime we're solving equations, we can do that if we see similar things on that side. Last step here, I'm going to divide everything by 6. And again, kind of the other way I can write it now, and as I'm getting used to, is just dividing every single thing by 6. As long as I do that, this will work in this equation. It won't change my answers. So on the left side, I just get y. On the right side, 12 divided by 6 gives me 2, so 2x. And then 6 divided by 6 is 1, so y equals 2x minus 1. So again, right now we're actually right in the middle of section 4.2, but this is something that will help us in this section and in the sections going on, so it's something I figured we better cover today.